Hey Sciencepect viewers, and welcome back to the channel. Imagine this, a machine built of metal and wires, not just assembling cars on a factory floor, but running, jumping, navigating complex obstacles with human-like agility, doing parkour. If you've seen recent videos from companies like Boston Dynamics, you know this isn't science fiction anymore. Advanced robots and humanoids are here, and their capabilities are pushing boundaries we once thought were decades away. For the longest time, our image of a robot was limited to those static, heavy industrial arms performing repetitive tasks. Essential, yes, but confined. The real world, with its uneven terrain, unpredictable environments, and complex objects, was largely off limits. But thanks to revolutionary leaps in artificial intelligence, machine learning, sensor technology, and advanced engineering, robots are breaking free. They're becoming mobile, autonomous, and incredibly capable of interacting with the real world in ways that seem almost alive. The most striking examples often come in the form of humanoids, robots designed to mimic the human form. Why humanoids? Because our world is built for humans. Stairs, doors, tools, vehicles, they're all designed around human proportions and movement. A humanoid robot, theoretically, could navigate and operate in these environments without needing a complete overhaul of infrastructure. Companies like Boston Dynamics have been at the forefront of this revolution. Their robot Atlas started as an impressive but somewhat clumsy machine. Now, we're seeing videos of Atlas performing dynamic movements, complex manipulation, even gymnastic routines, and yes, parkour. This isn't just for show. These feats demonstrate incredible balance, coordination, planning, and control. Abilities crucial for navigating unpredictable environments. Think about the complexity involved. To jump over an obstacle, the robot needs to perceive the obstacle's size and distance, calculate the necessary force and trajectory, coordinate dozens of joints simultaneously, maintain balance mid-air, and stick the landing, all in real time. This requires incredibly sophisticated algorithms, often powered by reinforcement learning, where the robot learns through trial and error, refining its movements over thousands of simulated attempts. It's not just humanoids. Quadruped robots, like Boston Dynamics Spot, show similar advancements in mobility and perception, navigating rough terrain, climbing stairs, and performing inspection tasks in environments too dangerous for humans. They use a combination of sensors, LiDAR cameras, force sensors, to build a 3D map of their surroundings, identify objects, and plan safe, efficient paths. Underneath these impressive physical feats lies the true magic: the AI. Computer vision allows robots to see and interpret their environment. Machine learning enables them to recognize objects, understand commands, and even learn new tasks without being explicitly programmed for every single scenario. Control systems manage the complex interplay of motors, hydraulics, and sensors to execute movements with precision and adapt to disturbances. Beyond locomotion, manipulation capabilities are rapidly improving. Early robot hands were simple grippers. Now, we're seeing dexterous manipulators that can pick up delicate objects, use tools, and perform intricate tasks. This requires advanced force feedback and fine motor control. It's driven by AI that understands the properties of objects and the physics of interaction. So, where could these incredibly capable machines be deployed? The potential applications are vast and exciting. Dangerous environments. The most immediate and perhaps least controversial use is in situations that are too risky for humans. Think disaster response, searching collapsed buildings, defusing explosives, inspecting damaged nuclear plants, or performing maintenance in hazardous industrial settings. Robots don't get tired, don't need oxygen, and can withstand environments that would be lethal to us. Logistics and warehousing. While robots are already common in warehouses, advanced mobile and manipulative robots could handle more complex tasks, like sorting varied items, loading and unloading diverse cargo, or navigating dynamic warehouse layouts alongside human workers, healthcare and assistance. In the future, highly dexterous and perceptive robots could assist in surgeries, provide physical therapy support, or offer in-home assistance for the elderly or people with disabilities, helping with tasks that require fine motor skills or strength. Everyday life and workplaces. This is perhaps the most debated area. Could advanced robots become common in our homes, helping with chores? Or in offices, performing complex administrative or physical tasks? The technology is getting there, but the social, economic, and ethical hurdles are significant. And this brings us to the critical questions these advancements raise. Potential benefits are clear, but we cannot ignore the challenges. Job displacement. As robots become capable of more complex tasks, concerns about job losses in various sectors become more prominent. How do societies adapt? What new jobs will be created? Safety and security. Ensuring these powerful machines operate safely, don't malfunction dangerously, and cannot be misused for malicious purposes is paramount. Privacy. If robots are equipped with sophisticated sensors and cameras operating in public or private spaces, how is our privacy protected? Bias in AI. Robots learn from data, and if that data is biased, the robot's actions and decisions could reflect and even amplify those biases. Human-robot interaction. How will our relationships with technology change when robots become capable of more complex social interaction or appear more human-like? Addressing these ethical and social questions now, as the technology develops, is crucial. It requires thoughtful discussion, robust regulation, and a focus on how this technology can augment human capabilities rather than simply replace them. The journey of robotics, from clunky industrial arms to agile humanoids capable of parkour, is a testament to human ingenuity and the accelerating power of AI. The capabilities we see today were unthinkable just a few years ago. While the potential is exhilarating, the path forward requires careful consideration of the societal implications. We are truly living at a fascinating time where the line between science fiction and reality is blurring. What do you think about the rapid advancements in robot capabilities? Are you excited, concerned, or a bit of both? Let us know your thoughts in the comments below. If you found this deep dive into advanced robots mind-blowing, give us a like and don't forget to subscribe to Sciencepect for more explorations into the cutting edge of science, technology, and space. Click the subscribe button right now. It helps us bring you more content like this. And check out our other videos on our playlists linked in the description. Thanks for watching, and we'll see you in the next video.